Overall, most scientists believe that the theory of how things came to be is still the best way to explain what happened in the universe's early stages. This theory blends the movement of stars, planets, and life on those planets, including life on Earth, into a very strange idea called the Big Bang. This article gives a good analysis of what might have happened at first. The universe was thick, with particles packed close together in an area no bigger than a pinhead. After this point, there was a huge explosion of matter and energy, which is known as the Big Bang. This event took place billions of years ago and set the stage for the history of the stars. Nevertheless, changes in valid data have led to more and more problems with this hypothesis's assumptions. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, scientists thought that its findings might back the idea that the universe began. The telescope shocked scientists with its ability to see a long way into the past of the universe after only a year in space. The amazing limits of the James Webb Telescope have revealed many systems that go back in time, so far that they make us question how we understand the beginning of the universe. This amazing discovery has made people think very deeply about what lived before the Big Bang. A big moment in this journey happened when cosmologist Rohan Natu, using data from the telescope, found a galaxy that formed not long after the Big Bang. It was the farthest galaxy that had ever been seen. Natu's findings shocked even the most experienced researchers and showed how powerful the James Webb Telescope really is. Its main goal is to change how we think about the universe, and it has only just started. It promises to give us surprising new information about the universe's early stages. This time period, which hasn't been talked about much, is important for knowing how the first stars and structures formed. The telescope's findings have gone against the original theories, showing systems with properties that are better than expected. This amazing flood of early systems has sparked a whirlwind of scientific inquiry, trying experts to see how these results fit in with what they already know. As scientists try to make sense of these new findings, they are faced with basic questions about the world and the forces that are shaping its evolution. As for the James Webb Telescope's steady progress, it is 1.5 million kilometers from Earth, away from any natural disturbance, and its tennis court-sized sunshield keeps it cool to almost absolute zero. The telescope has a huge, segmented mirror and very sensitive tools that are meant to show details about the early universe that have never been seen before. The cosmic dawn age began about a few 100 million years after the Big Bang. It was during this time that the first stars and galaxies started to form. There are still a lot of ideas about how this happened, ranging from the effects of dark matter and dark energy to how starlight, gas, and dust interact with each other. The view of galaxies from the Cosmic Dawn Telescope gives cosmologists a unique chance to see how well they can understand these complicated traits. By looking into these old systems, researchers can either find flaws in their current models that could lead to groundbreaking new findings, or they can find gaps in their understanding that do. At first, it was thought that the telescope would only be able to see a few faint, small galaxies during its test studies. However, it has seen a lot more than that. The telescope's first pictures of the faraway sky showed a lot of galaxies whose ages, sizes, and levels of brightness were different from what anyone had thought. Astronomers are racing to set new records for the earliest known galaxies because there are so many of them. New finds are being made all the time, which is amazing the academic world. As soon as the James Webb Telescope made its findings, scientists and astronomers rushed to find out more about these surprisingly evolved early galaxies. Some people think that these surprising results might be due to mistakes in how the telescope interpreted important observations. However, most scientists agree that these discoveries are a big change in how we think about the early universe and give us exciting new ideas about how galaxies might evolve. The James Webb Space Telescope's new findings about galaxies have led to deep questions about the universe's structure and called into question the basic ideas behind traditional models of the universe. Some researchers are looking into whether these findings can fit into theories that are already known, while others think they might be the first signs that the universe is much stranger and more complicated than we thought. The answer to this question could change the way we think about how the world we know today came to be from primordial chaos. The JWST's early findings could change the way we think about the past of the universe. They could give us new information about faraway galaxies and old structures, as well as about the Milky Way. You build these machines not to confirm theory, but to break it. says Mark McFan, senior scientist for science and research at the European Space Agency. You just have no idea how it's going to break. In 1985, before the Hubble Space Telescope was launched, the Space Telescope Science Institute, SDSCI, was founded. This is where the JWST got its start. At that time, G. Weir, who was in charge of SDSCI, had to think about what could come after Hubble. Even though some people didn't believe at first, Weir and a small group started making plans for what would become the James Webb Space Telescope. The JWST was made to look at things in the infrared range, not visible light like Hubble does. This lets it see much deeper into the universe. This skill is very important for studying faraway galaxies whose light has been stretched into the infrared because the universe is expanding, so cameras like Hubble can't see them. The JWST's huge mirror that looks like a cold star made it the best tool for solving the riddles of the cosmic dawn. The need for the JWST was made clear in 1995 when the Hubble Deep Field Observation showed a lot of galaxies in an area of the sky that no one had thought was empty. This finding showed how rich the early universe was and emphasized the need for a telescope that can look much deeper into the past of the universe. It took 20 years to build and cost about $1 billion, but on December 25, 2021, it was finally launched. It was ready to start its most important year of scientific studies in July 2022. Early programs, such as the General Observers Program and the Early Release Science Program, were made to look for galaxies that were formed very early on. At first, the results were not what was expected, but they were much better. Observations with the JWST have called into question current models of the early universe by finding galaxies that don't fit with what we know about cosmology. These amazing discoveries show how important it is to push the limits of scientific study and how powerful cutting-edge tools like the James Webb Space Telescope can be. As scientists keep looking at the JWST data, they might find more information that challenges and adds to what we know about the world. Cosmologists couldn't wait for the results to come in when the first data from the JWST started to come in. A lot of people had been getting their data analysis systems ready for years. Scientists decided to share their findings on preprint servers like AR-14 instead of going through the normal peer review process, which can take months. These servers are places where research papers are kept that have not yet been reviewed by experts. This method made it possible for a new type of peer review to happen on social media sites like Twitter, where scientists could quickly talk about their results. Rohan Nada called this science by press release, and the conversation that followed was both intense and had never happened before. But there were worries about the bad things that might happen because of how quickly the results were shared. Klaus Pontypool, a JWST project scientist at SDSCI, warned that sharing data quickly can help get the word out and start conversations quickly, but it can also make the process too busy. Most scientists agree that the theory of how things came to be is still the best way to explain what happened in the universe's early stages. This theory talks about how stars, planets, and life on those worlds, including us, have changed over time. The Big Bang, despite its strange name, gives us a good idea of what might have happened at the beginning of the world. There were many particles packed closely together in an area that was no bigger than a pinhead. At this very moment, there was a huge explosion of matter and energy, which is known as the Big Bang. This event took place billions of years ago and set the stage for the history of the universe. But as scientific data has changed, the beliefs that this theory is based on have become less and less true. Scientists thought that the James Webb Space Telescope's observations would support the idea of how the universe came to be when NASA launched it. It was the biggest and most advanced space science observatory ever made. The telescope shocked scientists with its deep ability to look into the past of the universe after only 1 year in space. The James Webb Space Telescope has amazing abilities that have shown us galaxies from so long ago that they make us question what we thought we knew about the beginning of the world. A lot of research is being done to find out what existed before the Big Bang because of this finding.